If you care deeply about wartime survival history and want to understand how ordinary soldiers stayed alive under extraordinary pressure, make sure you subscribe to the channel, leave a comment with your thoughts, and share this with fellow historians. This channel exists for serious minds who value real, field-tested knowledge. Today's topic is not entertainment history. It is practical wartime engineering born under fire, and it deserves careful attention. During the Second World War, soldiers on every front faced relentless aerial bombardment and artillery fire. Purpose-built bunkers were rare, time was limited, and supply lines were unreliable. Survival depended on improvisation. What emerged from trenches, forests, ruins, and open fields was a body of shelter-building knowledge that proved remarkably effective against bombs, shrapnel, and blast pressure. These shelters were not crude guesses. They were carefully layered systems designed through bitter experience, physics, and trial under fire. Why improvised bomb shelters became a matter of life and death. A 1-minute delay in taking cover could mean death. Soldiers learned quickly that foxholes alone were insufficient against heavy artillery or aerial bombs. Blast pressure traveled through open ground, collapsing shallow pits and suffocating those inside. Shrapnel ricocheted unpredictably. Improvised shelters became deeper, more complex, and better reinforced as the war progressed. German, British, Soviet, American, and Japanese forces all converged on similar solutions because the physics of explosions does not change with ideology. The key insight was that survival depended less on stopping the bomb itself and more on managing blast energy, fragmentation, and collapse. Every shelter was built around absorbing force, redirecting pressure, and preventing structural failure. This is where found objects became critical. How depth and earth became the first line of defense. The most important protective material was soil. Soldiers learned that compacted earth absorbed shock better than concrete when properly layered. Shelters were dug deep, often 2 to 3 meters underground, because blast overpressure diminishes rapidly with depth. The deeper the shelter, the less energy reached the occupants. To apply this knowledge today in a survival or historical reconstruction context, depth should always be prioritized before reinforcement. Digging below the frost line and tamping soil tightly creates natural armor. WWII soldiers often sloped entrances rather than digging straight down, forcing blast waves to lose energy before reaching the interior chamber. So, let's talk about how wood, scrap metal, and rubble were actually used as structural armor. Once soldiers managed to dig deep enough, the next big problem, really, was collapse. You see, bombs don't just kill with fragments, they also kill by, well, burying people alive. To fight this, soldiers scavenged timber from ruined buildings, old rail ties, doors, and even, believe it or not, furniture. Thick wooden beams were laid across the roof of the shelter, packed tightly side by side. On top of this wood layer, soldiers would add anything dense and heavy they could find: scrap metal sheets, rails, engine parts, stones, and broken masonry. All of it was piled above the beams. This mass layer helped distribute the impact forces over a much wider surface. Then above that, earth was returned and compacted down firmly. This layering really mattered. The wood flexed and absorbed shock, the metal spread out the force, and the earth smothered any fragments. The order was absolutely deliberate. If you reversed it, it often led to catastrophic failure. Even today, this principle still holds up. In any resource-limited survival scenario, flexible materials should always be placed below rigid ones with the dense mass above them. Even sandbags actually follow this logic. Now, let's look at how entrances were designed to defeat blast waves. Many early shelters failed simply because their entrances acted like funnels for blast pressure. WWII soldiers fixed this by building dogleg or zigzag entrances. A straight entrance would just let the pressure rush directly inside, but a bent entrance forced the blast wave to dissipate as it changed direction. Quite often, a short vertical drop was added just inside the entrance, creating a sump where pressure and debris could settle. Heavy doors were pretty rare, but thick wooden planks, sandbags, or steel plates were sometimes hung loosely to absorb shock without transferring it straight to the structure. So, in practical terms, this teaches us a crucial survival lesson. Openings are always the weakest point. Any shelter, whether historical or modern, should never allow a straight path from outside to the living space. So let's talk about how camouflage and placement really increase survival odds. Shelters that survived were more often than not the ones that weren't hit directly. Soldiers placed their shelters under trees, inside ruins, along embankments, or beneath natural folds in the terrain. Trees helped break up bomb aim points, rubble disguised entrances, and shadows hid activity. Camouflage wasn't just cosmetic. Fresh soil was darkened with ash or leaves, and paths were brushed out daily. Even smoke from cooking was vented through long, shallow trenches to cool and diffuse it. You know, this principle applies directly to modern survival thinking. Avoiding detection is often more effective than trying to resist an attack. In fact, concealment multiplies the effectiveness of even weak structures. Now, when it comes to keeping shelters livable, ventilation and drainage were absolutely crucial. A shelter that survives a bomb but ends up suffocating its occupants is, well, a failure. Soldiers cut narrow ventilation shafts, angling them away from likely blast directions. These shafts were reinforced with wood or even tin cans welded together. Drainage trenches were dug beneath sleeping platforms to prevent flooding. Honestly, this is one of the most overlooked aspects of improvised shelters. The experience of the Second World War shows that airflow and water control are just as vital as armor. Any practical shelter design must address both, or it risks becoming lethal over time. So, what can modern survivalists and historians actually learn from all this? The enduring lesson of Second World War shelters isn't really about the materials. It's about systems thinking. Protection comes from layering, flexibility, mass, depth, and smart geometry. Found objects only become effective when they're arranged with real purpose. A modern survivalist practicing shelter construction with limited tools can directly apply these methods using logs, scrap steel, packed soil, and thoughtful layout. And for a historian reconstructing these shelters, there's a deeper respect gained for the ingenuity and discipline needed to survive under constant threat. These weren't just desperate guesses. They were battlefield-engineered solutions, refined under fire. If this guide added value to your understanding of wartime survival and historical engineering, well, do consider subscribing to the channel, share this with someone who respects serious history, and leave a comment with the aspect you found most compelling. Your engagement helps preserve and pass on knowledge that was paid for with real lives.